Assalamu alaikum students. So today our topic is total internal reflection. Now what is total internal reflection? And there are two important necessary conditions in order to TR, TIR, total internal reflection, take place. What are those two very conditions? First of all, the ray has to go from that is the source should be in the denser medium. Or whether the source should be in denser or whatsoever, the ray has to go from denser to rarer medium. And the second condition is that the angle of incidence must be greater than critical angle for the pyramid. What is actually what I am saying TIR? We're having two media. This is a rarer one, this is denser one. When a ray of light is incident normally, it passes straight as it is incident obliquely. So at this very angle, now the ray goes from rarer to denser to rarer. Once it goes denser to rarer, it will go away from normal, from the rules. So as the angle of incidence increases, a stage is going to reach when the ray of light, the refracted ray of light, moves along the interface. That is, when angle of refraction is 90 degree. At that time, when refraction angle is 90 degree, then angle of incidence is called as critical angle. So what I am saying when a ray of light goes from denser to rarer, at the interface there is bending. If first it is incident normally, it will pass straight. As the angle of incidence is increasing, the refracted ray moves away from normal. As the angle of incidence increases to a stage so that refracted ray makes an angle 90 degree with the normal. At that time, the critical angle, the angle of incidence is called as the critical angle. Now, if you are going to increase the angle of incidence, now I have placed it here at I. Now I is greater than IC, where IC was the critical angle. Now once you are going to increase the angle of incidence beyond critical angle, now the ray will come back into its medium, in the denser medium from which it is incident, and this phenomena is known as what? TIR. So phenomena in which ray of light traveling back, is coming back into the denser medium, is known as TIR. Simply, I'm explaining what is TIR. TIR means when a ray of light goes from denser medium to rarer medium, but at an angle greater than critical angle. Critical angle is the angle for it is for a pair of medium. Let it be, if it is glass, it is water. If it is glass, it is air. So for glass and air, there will be fixed critical angle. But for a glass and water, there will be totally different critical angle. It is not fixed for every media. It is fixed for every two media. If a ray of light goes from one denser medium to another rarer medium, then there will be a fixed critical angle between them. So this angle of incidence in the denser medium, for which angle of refraction is 90 degree, is called as critical angle. You have to remember, what if somebody asks you what is critical angle, you have to answer it like this: critical angle is the angle in denser medium for which angle of refraction is 90 degree. Now it is for a pair of media, let it be glass and let it be water. Now if the ray of light is incidented at an angle greater than critical angle, as it is here, I greater than IC, what happens? Now there is no refraction, but what happens, the light comes back into the same medium, in denser medium. This phenomena is known as TIR, total internal reflection. Now there are two important conditions, two important conditions for TIR. Number one, what is that? Light has to go from denser to rarer. And second, Here the light goes from denser to rarer. Here it goes denser to rarer, but no TIR takes place. No TIR takes place. No TIR, but TIR takes place here. So the second condition is that angle of incidence, angle of incidence must be greater than critical angle for pair of media. Now let us see you some relation between refractive index of medium and critical angle. What is the relation between the refractive index of medium as well as the critical angle? Now in the diagram, as the ray goes from, this is medium first, this is medium second, now ray goes from here to here. So can I say by Snell's law, can I write n12 refractive index of this first medium with respect to second, because ray goes from this very denser to rarer, is generally sin I by sin r. Has the I is changing, the r is changing, but at I equals to IC, then R is equal to 90 degree, isn't it? So what then N12 become as? Then N12 equals to sin IC over sin of 90. Sin 90 is simply 1. Then we're having N12, which implies N12 equal to sin of IC. But we're having a formula, but N12 equals to 1 over N21. So which implies replacing here this, it will be 1 over N21 equals to sin of IC, or which implies N21 is equal to 1 over sin of IC, critical angle. What is N21? N21 is the refractive index of second medium with respect to first. So I will place it simply N. So N equals to 1 over sin of IC. This is the relation of refractive index of medium. It is refractive index was N, and to its critical angle. So this is the, so critical angle, refractive index is inversely proportional to sin of critical angle. So we have to remember this very relation, that refractive index is inversely proportional to the sin of critical angle. This is all for today. Tomorrow will be with another lecture. Till then, Allah Hafiz.